Let's recall what is a limit in very simple words. If a function f can be made arbitrarily close to unique value L by choosing x close to c but not c itself from the right and left of c, we say that the limit of the function f(x) x approaches to c equals L. It looks like this. First, the approach from the right. When approaching from the right, we actually has to approach on the graph from the right side of C, but it means that we are approaching as the values of the x's from the right of C are approaching C. When we have the left approach, we are approaching actually on the graph from the left side, which means we are approaching on the graph on the values of the x's that are from the left and are a little bit less than C. And we don't care about x equals C itself. When we do that, we get also that we are kind of getting arbitrarily close to unique value of L, which means that if we go a little bit more on the right side and more on the left side to shrink more about x equals C, then this stripe, the blue stripe about the L, is also going to shrink. Let's magnify that. Here is a vertical stripe about the C. Because when we are approaching right and left from both sides of C, if this is the distance between the right and the left approach, then in this stripe, this is a vertical one, and we get a matching one, which is the horizontal stripe, which is about y equals L. What happens if we shrink more about the C? This stripe is getting narrow. But also, the stripe about the L is now getting also narrow. If we can do this as many times as we like, shrink more about the C, and then as a result get a slimmer and a slimmer stripe about y equals L, it means that the limit exists. We can get even closer to C from right and left. We take an even narrower stripe about the x equals C, and because there's a limited L, we get another narrower stripe about y equals L. Now we are getting this one. If we can continue doing this forever, then the limit exists. The idea of the limit is then that if you shrink about the C, then you can shrink about y equals L. To shrink about the C, I would like the C to be in the middle of the interval at which x minus c in absolute value is less than delta, which means that the distance between C and the values that I'm approaching from left and right will be less than delta. To be very close to C is really being on this interval, when delta is obviously very, very small. When we do this, we get 2 points on the graph. We get one point, which is f of c plus delta, and we get another point, the function for the value of x being c minus delta. Now we want that those 2 points are going to be contained in a very narrow stripe about y equals L, because if there is a limit, those 2 red points supposed to be very close to the value of y equals L. Here is a narrow stripe about y equals L, and as you can see, the two red dots are inside. What does it mean to be a narrow stripe about L? It means that the higher point is between L and L plus epsilon, and the lower point is supposed to be between L and L minus epsilon, which means that the 2 points has to be here in this blue stripe. If there is a limit, we should get that for all those x's such that x minus c in absolute value is less than delta, which means that those x's are in this interval on the x-axis, we should get that for all those x's, f of x minus L in absolute value is less than epsilon, because they should be within the blue stripe. And we get the epsilon delta definition of a limit, which is the precise definition of the limit. We say that the limit of fx when x approaches c equals L if for any positive epsilon there is a positive delta such that fx minus L in absolute value is less than epsilon whenever x minus c in absolute value is less than delta. Example. Show that limit of x to the power of 2 when x approaches 2 equals 4. First of all, you want to see what really you have to show, so you replace the function fx by x to the power of 2 and L by 4 and c by 2. So we have to show that for every positive epsilon, there is a positive delta such that absolute value of x to the power of 2 minus 4 is less than epsilon whenever the absolute value of x minus 2 is less than delta. And again, the main idea is that epsilon is given to you and we have to find a matching delta. So again, delta depends on the given epsilon, so it has to be a function of epsilon. Step 1. We are going to find delta as a function of epsilon. From here, we would like to get that this guy is less than epsilon, so we have to work the absolute value of x to the power of 2 minus 4. It equals to the absolute value of x minus 2 times the absolute value of x plus 2. The reason I would like to do it is because I want to have the x minus 2 in absolute value somehow out of the absolute value on the left because of that. In the other problem, we had the x minus c in absolute value times a number, and it was very easy to find the delta as a function of epsilon. In this case, we will have to do some trick. We know that x approaches 2, so the value of x is almost 2. It's okay and right to say that x is between 1 and 3. So what is x plus 2? So x plus 2 is between 3 and 5, and the absolute value of x plus 2 is less than 5. It means that by replacing x plus 2 in absolute value by 5, I'm getting more. But if after making it much more, it's less than epsilon, then obviously the original one, the x to the power of 2 minus 4 in absolute value, is going to be less than epsilon. So now I would like this to be less than epsilon, which means that x minus 2 in absolute value must be less than epsilon over 5. Now it's step 2. We really want to show that for every epsilon greater than 0, there is a delta greater than 0 such that absolute value of x to the power of 2 minus 4 is less than epsilon whenever the absolute value of x minus 2 is less than delta. So let epsilon be a positive number which is given. We are going to take delta to be the minimum of 1 or epsilon over 5. Now we have to go forward, which means if x minus 2 in absolute value is greater than 0 or less than epsilon, we get that x minus 2 in absolute value is less than 1, because delta is or 1 or epsilon over 5 if epsilon over 5 is 1 or less, because it is the minimum of 1 and epsilon over 5. But from here, we get that x is between 1 and 3. And x plus 2 is between 3 and 5. And x plus 2 in absolute value is less than 5. Now we'll put everything together. I get that x minus 2 in absolute value is less than delta, and x plus 2 in absolute value is less than 5. So let's put everything together now. So x to the power of 2 minus 4 in absolute value, it's the product of the absolute value of x minus 2 and the absolute value of x plus 2. The first one is smaller than delta, and the second one is smaller than 5. So this product of the absolute values is less than delta times 5. But if you noticed, delta times 5 is less than epsilon over 5 times 5, which equals epsilon. Which means that x to the power of 2 minus 4 in absolute value is less than epsilon when x minus 2 in absolute value is less than delta. Again, as we did before, step 2 is just going backward on step 1, because in step 1 we have to go and see what we want to get, and for this is the delta. Now when we have the delta, we have to go back and to show that indeed the absolute value of, in this case, x to the power of 2 minus 4 is less than epsilon. And obviously, when we show that, by the definition of the limit, we get that the limit of x to the power of 2 when x approaches 2 equals 4.